Hi there, this is Jacob Nash, Precalculus Lessons, and this is, honestly, I kind of don't know. I at least know it's Unit 4, and I know what the lesson's about. I don't remember what lesson number, because it's been kind of a while since I've made a lesson. At least it seems like it. And I'm making this video a little bit differently, because I'm about to be tired of just, how it is, like, you know, how I've been making the videos before, if you've seen. So I'm just actually having an actual camera, and I'm just going to write and then hold the camera with the other hand. So this is going to be about the unit circle and how you can use the unit circle to find certain values. So there is you can memorize the unit circle, but that's not really a good thing to do, because that's not really going to help you in the long run. But basically, the unit circle is a circle, and it has a radius of 1 anytime you go somewhere around the circle. And there's kind of triangles that you can make out of it. And when you make the triangles, the hypotenuse is always 1 because the radius is 1. And so you'll have to remember a squared plus b squared equals c squared for the Pythagorean theorem. And remember trigonometry also. But as a review from geometry, there's certain special triangles, and there's something that you need to remember. Across from a 30-degree angle always is a side that is 1/2. That's something that you should know. Across from a 45-degree angle, there is always a square root of 2 over 2 side. And then a 60-degree angle has a square root of 3 over 2 side. So these are the three angles and what sides they are. So that's something to remember. So here's how we can use that. Let's say you're trying to find the sine of how about I'm trying to think of a good example. 120 degrees. And how do we figure that out? Well, we remember our reference triangles. Let's draw that. How do we know what quadrant it's in? Oh, well, 120 degrees, we would know that would be in this quadrant, because in between 90 and 180 degrees. And you'll have to do radians sometimes. We'll look at that in a minute. And so 120 degrees. So this is our hypotenuse, and then we will always draw to the x-axis. And if this is the unit circle, we know that side is 1. We always know that. And the whole thing is 120 degrees. This is, at least. But what is this? Well, if we know the full thing's 180, and that's 120, then this must be 60. But also you could just use your reference angle rules that we've talked about. But like I said, across from a 60-degree angle is a 3 over 2, square root of 3 over 2 side. Now, this is always a right angle side. And if you remember, all three sides, angles, should add up to equal 180 degrees. So, if we already have 90 plus 60 plus something equals 180, that something would be 30. So when you're on a unit circle, you'll always have 45, 45, 90, and 30, 60, 90 triangles. So this is a 30-degree angle. Across from 30 degrees is always 1/2. Now, 1/2 will be negative since we're going to the left. So these are our sides. So now, if we're trying to find sine, sine is opposite over hypotenuse. Opposite of, and this is about the 60-degree angle. Opposite of the 60-degree angle is 3 over square root of 3 over 2. And hypotenuse is 1. Oh, that's just that. So when you're doing the unit circle, since this will always be 1, what you can say is that sine is always going to be y, and cosine will be x, and tangent will be y over x, and obviously we know what our cosecant, secant, and cotangent would be, just the opposites of those things, 1 over y, 1 over x, x over y. And that makes sense because if this is O over h, A over h, and O over a, our O is always going to be our y, our A is always going to be our x, and h is going to be our hypotenuse, which is our radius, that's always 1 because it's a unit circle. So, the sine of 120 degrees is square root of 3 over 2. So that is how we can use the unit circle to find our values. That's what we can do. Now, there's also radians. So radians are a little bit tougher, in my opinion, but here's just a general rule. In this quadrant, you'll always have radian. This is just for the unit circle, keep in mind. In the first quadrant, we'll always have pi by itself on the numerator, and we can have 3, 4, 6 typically in the denominator. So basically we'll just say numerator is pi in the first quadrant. And keep in mind, if you have a denominator of 3, you will have a 60-degree reference angle. These are things that you need to know, and if you know these, you don't have to memorize the unit circle. If you have a denominator of 4, the reference angle is 45 degrees. And if you have a denominator of 6, then the reference angle is 30 degrees. And remember, those are those ones that we know. Across from the 60, square root of 3 over 2, square root of 2 over 2, 1/2. And you need to remember that here is, in radians, this is going to be 0 radians, pi over 2 radians. Think about it. If pi is 180 degrees, 90 degrees, doesn't that make sense? Pi radians, and then 3 pi over 2 radians is for this 270. So that's something you need to remember. So I would take notes if you don't know that. And also what I'm about to say. So first quadrant, numerator is pi. Second quadrant, the numerator, number that's in the numerator is going to be less than the number in the denominator. So that's first, second quadrant. Then the third quadrant, the numerator will be greater than the denominator. And then for the fourth one, the numerator is going to be equal to 2 times the denominator plus 1. So if we have 2d plus 1. So an example here could be 11 pi over 6. 6 times 2 is 12. Or sorry, that would actually be minus 1, not plus 1, sorry. 6 times 2, denominator times 2, that is 12, minus 1 is 11. So these are just rules so that you can always know, oh, that's what quadrant it's in. And if it might seem like, oh, that's kind of a lot to remember, but if you just remember these things for radians, you can figure out problems with radians. So let's look at an example now. Not all problems are unit circle, so I will need to, I'll be right back. I have to go get my notebook so I can look at an example. Okay, sorry about that. Kind of took a long time. So here's my notebook that I always use. Let me try to look at an example, because I don't want to give an example that's bad. It's not something that there is. Oh, okay. So, let's say we're trying to find this. Let's have a tough one. Cotangent of, how about, so this will be a radians example. 5 pi over 3. So, first thing we need to do is figure out what quadrant it's in. Okay, so remember here, the numerator will only have pi on it. The numerator has a 5 on it, so it's not going to be that. Here, the denominator is greater. That's not true, so it's not that. Here and here, the numerator is greater, so that's true. But one of them, the numerator is only 1 more than the denominator, and the other one is 2 times minus 1. 3 times 2 is 6, minus 1 is 5. So, it's this one. If it was 5 pi over 4, then it would be this one, because that's only, the 5 is only 1 more than 4. So, it's quadrant 4. And remember, in this one, cosine and secant are positive in that one, but we already know we're going to have a negative thing because cotangent isn't positive there. So now we'll draw our reference triangle. And by our rules that we said, the denominator is 3, so that means we have a reference angle of 60 degrees. So we would draw it like that. And 60 degrees is reference angle. We always know that our hypotenuse or radius is 1 because it's a unit circle. This, across from the 60 degree angle, is square root of 3 over 2. But it actually would be negative because it's down, it's below the x-axis. Here, since there's really a 30 degree angle here, because there's always 30, 60, 90, or 45, 45, 90 in a unit circle. Across from that is 1/2, and that would be positive. And cotangent, if you remember, tangent is opposite over adjacent, so adjacent over opposite is what it is. This is adjacent, this is opposite, this is hypotenuse. So 1/2 over negative square root of 3 over 2. We can flip this fraction and multiply it because that's what we can do for our reciprocals. So we would have 1/2 times 2 over negative square root of 3. That would be 2, and then 2 root of 3, and that's negative. Can have a root in the denominator, so let's multiply root 3. This becomes 2 times 3, so that would be 6 on the denominator, and then negative 2 root of 3. This simplifies 2, 6, that would become 1, 3. So negative square root of 3 over 3. If you don't understand how to do that, please see the video about simplifying radicals and things like that, because that's why we have the unit 0. And that's basically what it is. So, I'm going to do a quick review of things to know. So, first thing is unit circle. For a unit circle, hypotenuse is 1 always, or the radius. The second thing is what from certain angles, what is the side? Across from 30 degrees, that is 1/2. Across from 45 degrees, that is square root of 2 over 2. Across from 60 degrees is square root of 3 over 2. Ooh, sorry. And then the third thing is certain quadrants, what the radians are like. And this would have n, the numerator is pi there. the denominator is equal in there. The numerator is equal there. Basically, you add 1 to the denominator that equals the numerator. So that's a kind of a better way to put it. And then here, the numerator equals 2 times the denominator minus 1. And then, fourth thing is when there's a denominator of 3, you have a reference angle of 60 degrees. Denominator of 4, 45 degrees. Denominator of 6, 60 degrees. And remember SOHCAHTOA. And remembering those things, it should be pretty simple. As long as you know how to find reference angles and things like that we already talked about in this unit. But that is the last video of this unit, so thanks for watching, and I'll see you on the next unit.